everyone. Welcome back. Today we are going to be starting our new chapter. We're looking at chapter 6, which is trigonometric functions. So we're going to be really pulling in a lot of the information from chapter 1, where we were transforming all of our parent functions, and we're going to be doing the same thing in this unit where we're going to be graphing and curve sketching and making transformations for our trig functions. So we can actually graph sine, cosine, tan. Before we get to any of that, we are going to have to learn, again, a few definitions and some basics before we get into any of those periodic functions or those sine or cosine curves. So I did attach another file for you to print out. It's the Word document, and it's basically a little bit more clear because I do want you to do some of the work on your own here so you can clearly see it. So make sure you're printing that off so you can look at the rest of kind of the examples that we're going to be doing. So there are a lot of times in real life where you're going to see something called a periodic function. It's a repetitive pattern that we can express or explain or describe using mathematical equations. So the examples here, we talk about daylight hours. Every time the sun rises and sets, right? The amount of hours in a day. The tides, right? The height of the tides or the distance of the tides when they come in and they come out. We can look at temperatures rising and falling over the seasons, right? Cold temperatures in the winter, warm in the summer, cold in the winter, warm in the summer. And they repeat, and they would come up with some kind of cyclical or repetitive pattern if you were to graph them. So things like that would be examples of periodic functions in real life, which is why we would like to describe them in math. So basically, by definition, a periodic function is any function, right, any equation that can repeat itself. The y values would repeat over regular intervals of x. And you can see a repetitive pattern because there's a portion of the graph that would continue or that would repeat over and over. And we call this repetitive pattern, we call it a cycle. So let me just click on my pen tool so you can clearly see the repetitive pattern. It's outlined here in red, okay? And that would be your cycle of your periodic function. So if I were to start here and go up and down and up, when I get to this point, if I were to continue this graph, I would again see the up, down, and up pattern. And you would get kind of like a ziggy-zag all the way through if you continued it long enough. Okay, so this is the cycle. Now, the period of a function is the horizontal distance. It's how long it is. So if we were to start at x equals 0 and go, and let's say these went up by ones, 1, 2, 3, 4, 5, 6, and stopped there, this right here is the distance of our period or the period of the function. So this would have a period of 6 units in our case, right? So the cycle is the actual pattern and the period is the distance. Now, yes, there are formulas, right? x2 minus x1 to get it, guys. It's just how long it is. Peak and trough, that would be like the maximum or minimum of your periodic function. I like thinking about them. I always relate to things in real life. So a peak would be like the peak of a mountain, the top of a mountain. So your peak would be the high point or the maximum. The low point is called a trough, right? The minimum is called a trough. And if you think about what farm animals eat out of, cows, sheep, they eat out of a trough, which is like a basin or a bottom part. So high part is the peak, low point is the trough, maximum and minimum. Now, you'll notice though that repetitive patterns, ones like this anyway, have this beautiful line right here in between. In this example, it happens to be our x-axis, but you guys know that functions can move around your Cartesian plane. It's not always going to be the x-axis. So we need to have some kind of formula or way to figure out what that middle point is. So we basically need to take the average or the middle point of our peak and our trough. So take your maximum, add it to your minimum, and divide by 2, and you would get the line right in the middle, okay? So EOA stands for equation of the axis. Take the max and min, add them, divide by 2. And then there's this other word here, this amplitude. The amplitude is the distance, if you look at the graph, from the peak down to the equation of the axis, okay? So it's how high it is from the middle point. In order to calculate that, take the maximum or your peak, this time subtract the minimum or the trough, divide by 2, and you'll just get the actual distance. So when you subtract these, you're getting the full distance, cut it in half, and you'll get the amplitude. So the equation of the axis, sorry, the amplitude is this half part right here, okay? It's the distance from the equation up to the top. Cool. All right, moving on. So what I've got here is we're going to now look at your peak, your trough, your amplitude, and all of those fun definitions with this particular curve. Now this, spoiler alert, this is your sine curve. So this is y equals 2 times sine of x. You can get Desmos to graph it. I will at some point go over that with you. For now, just here's your graph. I've given it to you. And you'll notice that it goes up, it goes down, and this pattern would continue on and on. So let's just quickly identify the cycle, the peak, and the trough. So the cycle, I mean, you can start anywhere you wanted, but this is a nice, good starting point. It starts here, and I can see that the pattern goes up, it goes down, crosses the y-axis, the x-axis. Nothing's repeated yet. I come back up here. And then at this point, if the graph were to continue, it would repeat. So this part right here would be our cycle. Okay, so we'll call that A. Okay. Now, identify the peak. That would be the high point. Well, this right here looks like the high point. So that is our peak or our maximum. Okay, so that's B. And the third thing is our trough, which is our low point. And it looks like it's around here, okay, our low point. So our maximum is at 2. Our minimum is at -2. And then our cycle is here. Okay, so let's look at the bottom part of your handout. Okay, I'm hoping you printed it off. Looking at our curve, the period, remember, is the distance of your cycle. So I've started at 0 and it comes all the way and my cycle stops here. So the period for this function is 360. Okay, I have graphed this over degrees, which is why it's so big. Okay, and again, we'll get into that next section. So period, the distance is 360 degrees for a cycle. Our equation of the axis. So I'm going to take the peak or the maximum, I'm going to add it to the minimum, and I'm going to divide by 2. So let's just go back here. Okay, maximum plus minimum, divide by 2. So my maximum was 2. I'm going to add -2. You guys know that when you add a negative number, you're really subtracting. And then divide by 2, you should get 0. So our equation of the axis happens at x equals 0. Okay, and that's right here. So when x equals 0, we actually end up on our x-axis in this case, and there it is. Okay, the amplitude is how high it is. Okay, we can read this from the graph. It's 2 units high. If you would like to use your formula, take the maximum, this time subtract the minimum, and then divide by 2. Okay, so 2 minus -2 is 4. 4 divided by 2 is 2. Okay, and that's where our amplitude comes from. So in a scenario like this where it's easy to see the graph, you could read off of it, but this would be the formula that you could use to fall back on. And then domain and range. I've put the brace brackets here, or the curly brackets. Yes, I would like you to continue to use your proper notation. But just to kind of keep an eye on what's going on here, so just with the pen tool, if it's a little bit messy, I apologize. Domain would be all of your x values. This is a periodic function. It would continue on forever and ever in a rightwards direction, and it would continue on forever and ever in a leftwards direction. So my domain are all of the possible real numbers, okay? So XER, remember all those fun symbols? And that's it, it's all real numbers. The range going up and down, we can have a maximum of 2 and a minimum of -2 and all the values in between. So again, because you can have all the values in between, it's continuous, right? So y is an element of the real number system such that, that y must be greater than or equal to -2, but it must also be less than or equal to +2. And then you close your brace brackets. Okay, so a reminder going all the way back to chapter 1, how to calculate or how to come up with domain and range. So domain is the left and right numbers, range are the up and down numbers. Okay, so these slides are not on the document, the .doc file that I gave you. They are in the PDF though. So these are just a whole bunch of examples of identifying period, max, min, and some other kind of simple questions to go along. So if you're comfortable with it, you can pause and go to your work, but it is worthwhile to see some of these different graphs. Okay, so this is a blade that is going up and down. So this is the height of the blade over time. So the blade would be stationary. As time passes, it would cut down and come back up. And then, you know, the belt, I suppose, would move and then would cut down and come back up. So this graph just measures, just measures the height of the blade. So the period of our function, find two nice easy points that you could identify. I could go from here, but you know what? I'm going to see this bottom part because it's pretty easy to see, you know, down, up, over, down, up, over, down, up, over. It'll continue. So I'm going to start at this bottom point until I get to the next bottom point. This looks to be, now they go up by half a second. So this is 1, 2, 3, 4. So our period, or the period of this function, is 4 seconds. Okay. The maximum height, it reaches a maximum height of 0.5 centimeters. We can be specific and add your units. The minimum height, it touches the ground, so 0 centimeters. The time it takes the blade to go up and down. Okay, this is where the blade is already down. So for the time it takes for the blade to go up and then down again, they're actually, in this case, they're actually asking you for the period of the function again. So it would be 4. If they asked the period, if they asked you how long it takes for the blade to go down and up, then you would look at this piece, okay? Next time, oh, what is the next time at which the blade will strike the cutting surface? Well, we've noticed it's every 4 seconds. So it would be at 3.5 is when it touches the surface, at 7.5, because it's 4 seconds away. And then in another 4 seconds, it would be 11.5. Okay. So it would be 11.5 seconds, and that's it. Seconds. Okay, so today you are just looking at a whole bunch of different graphs. You're calculating the amplitude. I do want to see this one, but most of these are pretty straightforward. Okay, so looking at this one here, we have this is an end of a strip. So you can imagine that something's been marked and it's going in and around. So this is the height of the end of the metal strip. So as it's being pulled in, you'll notice that when it's down here, it's about 1 millimeter off the ground, but when it's up at the top, it is 9 millimeters off the ground, okay? So looking at this right here, the period, it appears to be from here to here, okay, about 0.25 seconds. Let's just double check. Yep, I keep looking at all of these and they are all 0.25 seconds apart. The range of the function, okay, we're going up and down. So the range would be all of the y values from 1 to 9. So you know the drill, y is an element of the real number system such that y must be greater than or equal to 1, but less than or equal to 9. Okay, don't forget your brace brackets. Okay. And that's your range. The equation of the axis, remember, that's the middle number right across here. So using our formula, and then we'll look at it on the graph, the maximum is 9. I'm going to subtract my minimum, and I'm going to divide by 2. Okay, it helps when I put the right formulas in. Sorry, this should be a plus, and this should be the minus. There we go. So the equation of the axis, the maximum plus the minimum would be 10. 10 divided by 2 is 5. Okay. And we can actually talk about that mistake in a second. So the equation of the axis, according to our formula, is right at 5, which is right here. It's straight across. You should notice that that is the middle section between the highest and the lowest point of your graph. When I threw the minus in, I went, wait a second, 4 brings me down here. And if you pop a line in at 4, okay, around there, you'll notice it's not directly in the center. There's a lot more space up top than the bottom. So I knew that I had done something wrong. Yeah, I gave you the wrong formula. I just put them backwards. So it's a nice way to double check your work. And then to find the amplitude, that's the distance from the highest point to your equation of the axis. So just, you can either count or you can use your formula. If I am counting, I'm going from 5 all the way up to 9, so it should be 4. Let's double check with our math. This one, I'm going to take 9 minus 1 divided by 2, right? My maximum minus the minimum divided by 2. 8 minus 2 is 4. Okay, so we've calculated our equation of the axis, the amplitude, our domain, our range, our period. It's all good. Okay. Hopefully you've got an idea of what a periodic function looks like by now. This one are each of these periodic? Yes, because it has a repetitive pattern, right? From here, squiggles down, and then here, squiggles down. It's the same thing. So this one, yes. This one, no. Even though it's going up and down, it's continually going upwards. There needs to be a cycle of some sort, and there isn't one happening there. This one, yes, because we've worked with a bunch of them. You'll notice the pattern repeats over and over and over. And this one, even though it goes up and down, there's no consistent or exact pattern that repeats. So no, this one is not a periodic function. Okay. Example 4 you can do on your own. It's just identifying range, period, equation of axis, and amplitude. And this is a word problem. It is from your textbook, so you can look at the solutions on your textbook. Okay. Anyway, it's a pretty straightforward lesson. I know I took a little bit of a long time to do it, but please go over, review, and today you're just being comfortable with what makes a periodic function or sinusoidal function and learning the different terms like period, equation of the axis, amplitude, and stuff like that. Okay, guys, have a great one. We'll see you next class.